Hello, fake data fans. Welcome to today's event in which we are shining the spotlight on the top 10 data generators you need to know about with Tonic AI. We're hosting this event to celebrate the release of our newest ebook, The Great Big Book of Data Generators. It's basically a data mixologist's guide to faking data responsibly. If you haven't grabbed your copy yet, head on over to Tonic AI. You can click the Learn button in the nav bar, and you can find all of our free ebooks there. I'm also going to go ahead and paste the link in the chat for our live audience in case, where did I lose? I lost my chat. If I can do this, here we go. Chat, there we are. It's over here. Okay, that way everybody in our live audience can access the ebook. That work? There we go. Oh, I posted it twice. Okay, cool. All right, so now we all know why we're here. I'm happy to introduce you to who we are here with. I'm your host, Chiara Colombi. I'm the product marketing manager here at Tonic, and I'm very happy to be joined today by my talented coworker, Dylan Sweetwood. He is a customer success manager here at Tonic and a master mixologist of data generators. Thank you so much for joining us, Dylan.
Yeah, no, my pleasure. Thank you for having me.
Of course. One last note before we get started, we do welcome your questions. And we'll leave plenty of time for them at the end. We'll have a Q&A session. So feel free to put them in the Q&A function of Zoom. We'll also look out for them in the chat if you put them there. And we'll be sure to get to them at the end of our presentation. Cool. All right, let's get started. I think, Dylan, to begin, I think it would help to kind of level set on a couple of concepts and capabilities that are key to understanding how Tonic's generators work. So my first question for you is, in a nutshell, how would you describe what we mean when we say data generator?
Yeah, good question. So in the context of Tonic, a generator is an algorithm that's built to generate a specific type of data. So to transform input data into output data. This can be really simple. So for example, we have our name generator. The name generator de-identifies names by replacing them with names from a preloaded library. Now we also have really complex generators, and we're going to see a couple of those today. But Tonic offers more than 50 generators in total. So there's a ton of different ways to transform your data.
Yeah, 50 plus. And I think I'll also add, we're adding new ones all the time, based on customer requests or new data scenarios that come up. So that number is not static. Awesome. So we know we can generate a plethora of data types in Tonic, and that's all well and good. But we also know that data sets are not made up of independent freestanding data, each in their own column, doing their own thing. Data sets are all interconnected, right? There's complex relationships. There's data points that appear in more than one place, foreign keys that reference back to your primary keys. How do we capture that complexity and preserve referential integrity along the way?
Yeah. So the short answer is that we do that in a ton of different ways. But maybe it would be helpful to go over like a few core concepts that help generators preserve the complexity that you're talking about.
Yeah.
So the first of those concepts is linking. And linking allows you to tell Tonic that two or more columns with the same generator applied to them have an underlying relationship. So like an interdependency or correlation that you want to preserve. An example of this would be a table with different columns for city, state, zip code, that type of info. Obviously, all this data is going to be related in the original data set. So if you want to preserve those relationships, you have to link those columns together. The next concept is partitioning, which is kind of similar to linking, but partitioning allows you to recreate distributions in your output data based on distributions in your input data. So an example of this would be a column for, let's say, income and a column for job title. It stands to reason that one's income might be a dependency on one's job title in this kind of data set. So if you partition the income column by the job title column, incomes are going to be redistributed in your output data to be dependent on those job titles, which should more closely align with the original distribution of your data while still being de-identified. And the final concept I'll just kind of briefly talk through is consistency, which is very simple, but very powerful and also very useful. So by making a generator consistent, you're going to ensure that the same input always maps to the same output across columns and tables throughout an entire database. So an example of this would be email addresses, right? These are usually unique, but they can occur multiple times in multiple different places across a data set. And if you enable consistency on every email address column throughout that data set, the same input email is always going to transform into the same output email.
Very cool. Yeah, I know that consistency in particular, it's like vital, used by so many of our
Yes.
customers. And I imagine we're going to see kind of each of these concepts that we've described in action today, right?
Yeah, definitely.
Very cool. Okay. Yeah, another thing I'll say is kind of the functionalities that we've described so far respond to the challenge of ensuring the realism in your data. But I'm going to add one more concept to really speak to something that responds to the challenge of ensuring the privacy of your data, and that is differential privacy. This is an option that you can toggle on for a variety of the generators in Tonic. And what it does is it makes that underlying algorithm of the generator differentially private. So I basically said differential privacy makes things differentially private. Fantastic definition. Let me try again. In a nutshell, differential privacy refers to the practice of adding statistical noise to data sets. So it makes it impossible to identify one given, any given real world record within the data set, and it kind of softens outliers as well. So if you can imagine like an income column, you might have one person in that income column that makes $5 million a year, and everybody else is more in a normal range. Well, you don't want to de-identify that $5 million income in a similarly high number. I'm sorry, can you hear the lawnmowers outside?
No, I can't.
Hopefully not.
You're
Apologies.
good.
All right. So differential privacy basically helps you rein that outlier in by adding noise and softening the data overall. All right. So yeah, it kind of provides a mathematical guarantee of privacy, is what I'd say, to prevent data re-identification. And we're proud to offer it here in Tonic. All right, I think we've covered kind of all the core concepts surrounding our generators. Now let's get to the generators themselves. Here's how this session is going to work. I've got a bunch of unique scenarios, and I'm going to kind of pitch them to Dylan so we can talk about some of our most interesting generators by kind of counting them down in a greatest hits top 10 list. Very subjective, Dylan and I worked on this list together. It isn't based necessarily on how frequently they're used, but it really does help spotlight some scenarios that we commonly see and that can be very hard to solve for. Are you ready?
Yeah, let me go ahead and share my monitor. So if you can let me know when you see it, please.
Yep, looking great.
Awesome. All right, good to go.
Okay, so we're going to start with number 10 and work our way down. Here is scenario number 10. And I will say, we hear this one all the time. It's like guaranteed to come up on webinars in particular as a question. And here's the scenario. I want my names to look realistic in relation to the rest of my data, like gender, title. But the name generator, if you just use it on its own, it pulls from a library of names and it doesn't take other data in your data set into account. So how can I ensure realistic first names in relation to other fields in my data, like gender?
Yeah, this is a good one to start with, a little bit of an easy one. So we're going to do this using one of our most common and most useful generators, and that's the categorical generator. What categorical does is essentially randomly shuffle all of the values in a column. So if I take a look at our gender column right here, click this dropdown, and then apply the categorical generator, the existing distribution of values is going to be shuffled around and preserved in the output data as well. Now, if I also apply a categorical generator to the first name column here, as in your example, oh, that's character scramble. Oops. Let's apply categorical. I have the option to link this generator to the gender column as well. And what that's going to do is ensure that the underlying relationship between these columns and these values is preserved. So, for example, if the first name Kelly is associated with the gender value F in the original data set, that linked relationship is going to be preserved and persist in the output data. One more thing I'll just kind of quickly note about categorical is that it shuffles existing values. It does not create new values from scratch or pull them from a library. So the name generator is an example of a generator that pulls from a library. This is great if you want to end up with realistic data, but it might not be the best way to ensure privacy because, as we can see, the first names are still the same as they are in the original data set.
Yeah, that's a great thing to flag. But I still like this workaround because, like you said, it's very simple and you might not immediately think, oh, categorical is a great generator for first name, Yeah. So I think it's a cool scenario to show. All right, staying with names for a minute longer. Generator in the number 9 spot on our list solves this scenario. I am a B2B business and I've got a list of customer accounts in my data that I need to obfuscate because those customer accounts are proprietary business information. That said, I still want them to look realistic. What's the best generator to use here?
Yeah, this is a good one. Obviously, with something like company names, the categorical generator is not going to work because even if those names are shuffled around, the fact that they haven't been transformed in any way is a problem. That business information is still going to be visible in the output data. Wouldn't you know it, we actually have a generator called company name that I think is perfect for this type of scenario. So I'm actually going to navigate to the stores table in our data set here. One thing I want to note is that this is a totally fake retail data set. So this is probably not like the absolute best example here, but if I click on the store name column right here and then apply the company name generator, those already fake store names are going to be replaced with even more fake sounding company names. And some of them are even kind of businessy. You've got things like factory, systems, international, worldwide. Essentially, the output data from this generator is still going to be somewhat realistic while still being totally unidentifiable.
I really want live shooting star services, I think is what that says, to be a thing. Because if somebody can like tell me where the shooting star is going to be, I want that. I don't want to have to sit and wait around. That's
yeah, it sounds professional, right?
Right. Yes, very. What else do we have? Silver Stag Worldwide.
Yeah, No Strings International. Yeah, some of them are pretty crazy.
Cock-a-doodle-doo Inc. down there towards the bottom. Awesome. There's a lot of stories in there.
Yeah, no, this is, I'll say this generator is definitely a customer favorite. It's an internal favorite as well. I've seen some pretty funny examples. I'll say just as a caveat that I think it's theoretically possible for this generator to generate a real company name or real business name. I guess what I'd say to that, if that happens to you, is that company name is ridiculous and should probably be changed in the real world.
Good flag. Yeah. Awesome. All right, let's go to number 8 on our list, and let's switch gears a little bit and tackle something more complicated because those examples were pretty simple, right? So here's the scenario for you, and I'm going to leave it somewhat open-ended. Is there a way that I can use multiple generators within a single column, applying different generators depending on the values found in that column?
Yes, that is possible. So far we've been talking about applying discrete generators to columns that will uniformly de-identify all the values in those columns. But it is possible, as you're asking, to apply multiple generators in a single column. And the easiest way to do this, and probably the most common way, is the conditional generator, which allows you to set conditions within a column and then apply different generators to those different conditions. So to demonstrate this, I want to go back to our customers table and scroll over here to the email column. So with email, ordinarily, there's like a couple different options for generators that you might want to use on this type of data. If I apply the email generator, what that's going to do is preserve the email address format, but otherwise totally scramble the underlying email address data. So we can see here, it's totally nonsensical. This is a great option in some cases, and you can actually even specify like real email domains here. So if I want to have each of the domains be at gmail.com, but have the first part be totally scrambled, that's possible as well. But to go back to your question, Chiara, let's say that there are some email addresses in this data set that you want to mask differently or not uniformly. So in that case, instead of applying the email generator, go ahead and get rid of that. Let's apply the conditional generator. And we'll go ahead and set the default condition here to the same settings that we had before for the email generator. So the email generator is applied here, and then gmail.com is the domain. We can see down here that data is pretty similar to what we were just seeing. But now we're going to add a condition. So I'll click the condition here, and we're going to try to identify all email addresses in this column that contain a yahoo.com email address. And for the generator, we're going to apply null. So we're going to null these values out. Essentially, what this does is null all of that data from the input data to have it be absent in the output data. I'll say that this is a little bit of a contrived example. You can kind of see how it's working here. But for email addresses specifically, there are a lot of applications of this that I've seen. Do you know the Gmail trick where you add a plus after the first part of your email address and it creates like a new variation?
I've used that so much, I don't even know how many variations exist.
Yeah. Yeah, no, I use it all the time too, especially when I'm like signing up for stuff, free trials multiple times. It's great, but you may not want that type of email address data in a data set like this, or if it's like a database of app signups or something. Or here's a different example, right? So you want to remove all of the internal email addresses from a data set. So you set a condition to identify those domains and then remove them. Just to wrap this up, I will say that conditional is one of the generators that I recommend most frequently. Super useful, and you can apply almost any normal generator from within a conditional generator. So the possibilities here are really limitless.
That's awesome. And I know it's kind of tricky to demo because of that. Like what do you show? There's so many options. So thank you for what you did show. That was great.
Yeah,
and that kind of the ability to apply more than one generator within a column, it does remind me of generator number 7 on our list. I'm just going to go ahead with a big reveal here. Clocking in at number 7 is our Json mask generator. And Dylan, I'd love if you could show us how it's used generally speaking, but I also do have a more nuanced scenario for you to tackle.
sure.
I'll get to that now. So I've got data in JSON blobs, but I don't know exactly what's in there. And it's also changing, potentially adding sensitive data after the fact, after I've already applied the protections that I thought I needed. So how can I ensure that nothing slips through sensitive-wise in my JSON blobs when I don't even know what's in there?
Yeah, no, this is a really interesting scenario, and one that I think is pretty common with JSON data, other types of data as well. Let's start maybe by going over the JSON mask generator itself. So if I scroll over to the right, we actually have some JSON data in this data set, which is super helpful. I'm going to apply the JSON mask generator right here, and then click Add Generator to open up our JSON mask editor. Now, what's really cool about our JSON mask generator is that it allows you to specify path expressions yourself right here, or you can actually click on the data on the left over here to specify individual path expressions that you want to apply generators to. So for an example, I'm going to click on last name right here. I'm going to select the name generator that we talked about earlier. I'm going to specify last name. And something else that's kind of cool here is that I can turn consistency on within these generators in the mask generator, and it will still be consistent with any other consistent generators in my data set. So let's actually see that in action here. I'm going to click save. We can see that within the JSON string, the last names have been de-identified and replaced with new fake last names via that name generator. I'm going to scroll back over to the last name column and do the same exact thing. So we'll apply the name generator, select last name, toggle consistency on, and we can see Spadoni is the last name that is generated here as well. Very cool.
Yeah, that's awesome.
Yeah. So to go back to the original scenario that you were talking about, where you have data that is maybe changing in the JSON blob, being added, you're not really sure what the boundaries are. One thing I think is really cool and useful about the JSON mask generator is that there is an option to apply a generator to all path expressions, sort of like a default. So if I go in here and click Add Generator again, open up the editor, and then type in ... asterisk for the path expression, it's going to show me all of the matched JSON values here. And I can select a generator to apply uniformly to all of them. So we'll just go ahead and use character scramble as an example here. I'm going to save this. If I want this to be kind of like the default generator or the first step, I actually will want to move that above the last name generator that I have here, so that this action is completed first, and then this generator is applied second. So we can see here in the underlying data, everything is character scrambled except for the last name path expressions that have been replaced with fake last names. Yeah, so that should hopefully answer that that more complex scenario.
Yeah, that's so helpful. And then you can just keep on applying for the data that you do know in the JSON mask. You can keep on applying other generators below, and that, yeah, that's awesome.
Actually, yeah, it can get pretty complicated depending on what you want to do.
Yeah, well, but guess what, folks? The complex masking doesn't stop here. Let's go to generator number 6 on our list. Here's the scenario I have for you. I have a long string of data and I want to mask specific components within that string using different generators. What can I do to solve this problem?
Yeah, so when it comes to masking strings of data, especially if they're not in a common format like JSON, I would say the regex mask generator is going to be your best bet. So regex mask doesn't require input data to be in a particular format, can be applied to pretty much any column. So let's see, to demo this, let's go over to the email column here. I'm going to remove the generator that we have here. And then let's apply a regex mask instead. Open this up. And if I click add regex, what I can do here is designate capture groups within a string that I can apply specific generators to. I'll just say for the audience and for you, Chiara, I'm not a regex expert by any means. So I'm just going to use a really simple expression here to essentially capture all of the data prior to the @ symbol in these values. And remember, this is an email address column, so we can make the assumption that there's an @ symbol in every single value. So if you remember, we originally applied the email generator to this column and it just scrambled everything. But now that I've identified this capture group, if I apply the name generator to it, so we'll select name, we'll just do first name for this one, and then click save. What we're going to see is that each of these email address values have preserved the original domain after the @ symbol, but everything before the @ symbol has been replaced with a fake name.
And you could make that consistent with other, fake names within the data?
Yes. Yep, you should be able to.
That's so cool. I know you said you're not an expert, but you're more of an expert than I am. I'm very grateful for this explanation because to me, it's like the choose your own adventure of generators. You dictate what how you're going to fake it within just one field at a time. That's just so cool.
Totally. And if you are a regex expert, right, there's a ton of different ways that you can apply this type of logic. This is a super basic example, but I have a lot of customers, for example, that have endlessly long strings that they need to parse and de-identify in really specific ways. So that's where I would say this comes in handy pretty often.
I'm probably going to call this one out as my favorite. It's like between that and conditional, those two are really just awesome in my mind. All right, so we've been talking a lot about generators that have a wide range of possible applications, but many of our generators have a much narrower yet still very important use case that they're solving for. So let's look at one of those for generator number 5 on our list. And here is the challenge, should you choose to accept it. We are dealing with HIPAA regulated data, and we've got addresses in the database, not just street, city, state, zip. We've even got latitude and longitude. And for the data to be realistic, obviously, we need all of those fields to correspond. So if you're in a certain zip code, the latitude and longitude should actually fall within that zip code. But for the data to be HIPAA compliant, we need them to meet the regulatory requirements around protecting data in low population areas, for example. And that includes lat-long. How can we do this?
Yeah. Good question. When you said, narrow application and challenging, I thought maybe you were going to mention like the shipping container generator. I'm glad you did it. No, I think the HIPAA compliant generators are really cool to spotlight and very important too, given how many customers we have in the healthcare and health tech spaces. So yes. Super common scenario. Let's look at how we would solve this. I'll just go ahead and say it. The best generator to use in the scenario that you mentioned is fittingly called our HIPAA address generator. So we have a HIPAA address generator and an address generator. The regular address generator is compatible with all the different types of address data that you mentioned and then some, right? So city, state, lat, long, zip code, etc. What makes the HIPAA address different and more useful in this case is that it will generate address data that is both HIPAA compliant and realistic with respect to the input data. So we're going to see this in action here. I just go to the stores table. Let me scroll all the way over to the store zip code column. We can see here it's got zip code values. I'll just start by applying the address generator so we can see what it does. I will select the zip code option. And then we can see here that all of the zip codes that are generated are random. So they have no bearing whatsoever to the original input data. And that may be fine in some scenarios. But now, if I instead apply the Hipaa address generator, I'll select zip code. And then I'm also just going to take the additional step of toggling this truncation off. We can see the zip codes that are generated are much closer geographically to the original underlying zip codes. And one way to just verify that really quickly is toggling preview on and off. So right here we have 78710, and that is being transformed to 78738, which is pretty close geographically. To make this even cooler and more complex, I'm also going to apply the Hipaa address generator to the latitude column. We'll select latitude here, and then I'm going to link it to store zip code. I'm going to do the same thing with longitude. So I'll select longitude here, go ahead and link it. And then we can see, again, by toggling preview on and off, that the values now in all three of these columns are aligned and realistic with respect to the underlying data. So that's, how you would ensure both that privacy and that realism for something like HIPAA compliance.
For me, that's super magic going on in the back end and the algorithms. That's just really, really awesome. And I imagine this must be one of our most, I don't have data to back this up, but I would imagine it's one of the most frequently used generators among our healthcare customers in particular.
Yeah, even outside of healthcare, I would say it's used pretty commonly. But if you do have HIPAA compliance as like a privacy consideration or as a mandate, obviously this is really commonly used there.
Okay, and I do see a question related to Hipaa that if I can just ask you quickly, and we can also get to it at the end if we need to kind of crowdsource an answer.
Yeah.
Is closely generated Hipaa zip code, can it be the original one as well? Would it ever generate to the original? I'm pretty sure the answer is no.
Oh yeah, the answer to that, I'm like 99% sure the answer is no. I think it would be good to just confirm that, but yeah. My reasoning is that would completely defeat the purpose of HIPAA compliant generator.
Yeah, the algorithm's designed to not do that, basically.
Yeah. We'll just double check on that, but I'm pretty sure the answer is no.
Yeah.
And same with all of the values that the Hipaa address generator. So it would never be the same latitude, longitude, etc. Okay. Just actually, Chiara, if you don't mind, while we're on that topic with regard to Hipaa, something that this generator will do as well, if it's a really low population density area, the generator will take that into account as well. So it's not just going to generate a zip code, 1 over from the low population density area. It'll widen the scope ever so slightly. I can't speak to the specifics of that because I don't know exactly how it works, behind the hood, but something else to keep in mind there with HIPAA compliance.
Yeah, I think that all comes down to safe harbor. If for us to be able to call the generator HIPAA compliant, it has to make sure it's protecting and not either being too close in the same low population area or not spitting out the same result.
Yeah, that's about the extent of my knowledge there. So any more granular HIPAA questions, we might have to defer to somebody else.
yeah, and we've got we can source some answers as well.
Yeah, for sure.
We do have another question here. I knew HIPAA was going to be a popular topic. For the address generator, is it HIPAA compliant? That does it meet standards from HHS? You mean Health and Human Services? HIPAA compliant. We mean we enable you to create data that is safe harbor compliant. So yes, it meets those stringent regulations. If by HHS you mean Health and Human Services, that's the government organization, right? That manages HIPAA.
I would think, yeah.
Yes. Then the answer to that question is yes.
Yeah.
All right.
And sorry, really quickly, just speaking to how our customers are using this too, right? We have actually and we, like Chiara was saying, make improvements to these generators all the time, including improvements to the HIPAA compliant nature of these generators. And they're pretty sophisticated by now. So the fact that we have, quite a large number of healthcare and health tech companies relying on this generator, they're pretty sophisticated and pretty thorough with regard to compliance.
Yeah, actually, that's partly why I brought up lat long today, because that's something that we recently added to the HIPAA address generator as a feature, a customizable feature. All All right, so we're going to stick with the Hipaa theme a bit longer since it is so popular to spotlight the generator coming in at number 4 on our list. We're already at 4. Location data isn't the only kind of data subject to Hipaa compliance. So this might answer some more questions from folks in the audience. Dates are another common example that must be Hipaa compliant. What generator does Tonic recommend to mask, for example, birth dates or medical appointment dates in a Hipaa compliant way?
Yeah, good question. So one generator I think that I see a lot used with that type of information, I think makes a lot of sense to use, is the date truncation generator. So let me actually navigate back to the customers table, and we have a birth date column over here, which is super useful. So like you said, birth dates are often an obviously identifiable type of personal information. Unfortunately, they're also often like really important to preserve in, underlying data sets. So this allows you to kind of meet somewhere in the middle. If we apply the date truncation generator to the birth date column, what we're going to see is that the month and day of each date is changed to January 1st, but the original year is preserved. So this is really helpful, for example, if you want to preserve like a general distribution of ages in a data set while still de-identifying those individual birth dates, which would be considered, PII or PHI. And this would actually work for something like appointments too. So there's the option here to truncate by month or day instead. If we truncate by month instead, essentially what you would be seeing here is like which month an appointment was scheduled in without seeing the actual day, which again could lead to re-identification. Mm-hmm. And then one final thing that I think is cool and useful to point out about the date truncation generator, if we click on this birth date toggle, what that's going to do is modify any dates in this column that are more than 90 years before the current date to be exactly 90 years before the current date. Now, why would you want to do this? By doing this, you're ensuring that you're compliant with Hipaa's safe harbor provision. And if you think about it, it makes a lot of sense. So if you've got individuals in a data set who are older than 90 years old, or dates that are older than 90 years old, think about people who are 105, pushing 110, it's going to be so much easier to re-identify those individuals, even from anonymized data, like if you've removed the birth month and birthday, and that's why that whole provision exists. So super helpful option for things like birth dates, especially if you have, people who meet that criterion in your data set.
Yeah, it's kind of like a simplified version of differential privacy. Let's just wipe out the outliers.
Yes, exactly.
Yep. All right. I think that's a really interesting approach to de-identifying dates, and it's great that it's safe harbor compliant. That said, for other use cases, it kind of feels like an axe, just like truncate all the way down to January. For the prize spot of number 3 on our list, and I say prize because objectively we all know 3 is the best number, what generator can I use if I just want to slightly fudge the dates in my database?
Yes. Okay. Good call out. Right. Tonic has a lot of different ways to de-identify dates and times. It's not just date truncation. Maybe let me actually show off a couple of these. If I just go over to last transaction here and apply the event timestamp generator. So for example, what this does is it looks at the underlying distribution of event dates and then shuffles all the dates within those, randomizes all the dates within that distribution. Now, if I do random timestamp instead, it's the same concept, but you can actually set your own distribution and your own range within which to distribute those dates. So both helpful options, right? To answer your question more specifically, I think the generator that's going to be most helpful in terms of shifting dates by a certain amount is actually timestamp shift. So if I apply timestamp shift here, what this allows you to do is set a minimum and maximum number of days so that all the dates are going to be shifted a random amount within that range. And this is really great, for example, if you want to shift all the dates like within the same week. So it's still technically de-identifying them, but the output is way more realistic with respect to the input data than any of the other date and time generators that we've seen.
That actually might speak to the question that we did just get in the chat, so I'm going to bring it up now. For date and Hipaa, specifically event dates, is there a way to maintain longitudinal data, for example, order of events? So I think that kind of speaks to it, but I also have a question for the question asker. By longitudinal data, are you meaning like from one column to the next, birth date has to happen before, first doctor's appointment, obviously, or is the question about row to row dependencies? So like, there was a customer transaction, customer one had a transaction here, and then down, further transactions on the list. I think there's two different answers to that question. But I do think that Dylan, you did a great job at showing us kind of all the possibilities with dates. So maybe
go
ahead.
Yeah, I was going to say, I think I understand the question as well. Let me know if this doesn't answer it and we can, circle back, or maybe I can answer it afterwards. Generally, it is possible to link dates sequentially in that way, right? So if you know, for example, that birth date has to occur before, this is such a this data set is really not great for Hipaa examples, but like has to occur before last transaction, which does make sense, but is kind of nonsensical. That is possible. I think it might be a little bit tough to demonstrate here, but what you're talking about is built into the way that these generators work. So by linking them together, you'd be able to accomplish that exact thing.
And we do have a bit more clarity from the question asker. Row to row is what they're interested in. And I do know the answer to that, which we are going to be getting to in just a few generators. Where are we in our list? We're down to 2, right? Yes, I just did 3. So the number 1 generator is going to be of interest. And I'll just leave you on tenterhooks because let's go with number 2. All right, I'm going to toss out a big critical problem that I'm pretty sure every single person de-identifying their production data needs to address. And that is, how do I de-identify primary keys in my database while still keeping them useful, unique, and tied to my foreign keys?
Yes, definitely a bit of a transition from HIPAA compliance, but still really important. I'm glad we're talking about key generators. So there's a couple different types of key generators that you can use for this kind of scenario. You've got integer keys, UUID keys, alphanumeric string keys. There's even more than that. And Chiara, like you were kind of alluding to, these generators are usually used on primary key and foreign key columns, and they have 2 special properties compared to other generators. So the first property is that key generators will always generate unique values, which is often necessary to respect the uniqueness constraints of those key columns. And the second is that they're always internally consistent. So when one of these generators is applied to a primary key column, links to any foreign key columns are not being broken because that internal consistency is ensured. This is again where the limits of this sample data set is, are starting to kind of show through. But I think I've got a couple of ways to maybe show off some of these capabilities. This is a primary key column right here. We can tell that by the little golden key icon right here. And if I click to apply a generator, what Tonic is going to try to do is suggest the type of key generator that seems to make the most sense for the underlying data. So right here, if we select integer key, what's going to happen is that the integers in this column are going to be replaced with random unique integers to replace those key relationships. Obviously, they look pretty different than the data looked just a second ago. But if you wanted to specify a minimum or maximum range for these integers, you can do so. And that would be helpful if you want to preserve, like, the aesthetic integrity of the data, essentially. Let's see here. One of the other ways I think I want to show this off, let me just go to this generator here. Again, weird example, but if I get rid of the categorical generator on the name column and then apply an alphanumeric string key, yeah, okay, this is a good example. So again, like I was saying, key generators use format preserving encryption to generate the new values. So if we take a look, toggle preview on and off, these underlying values are going to be the same length and use the same types of characters or type of format as the underlying data. So again, we can see that as we toggle preview on and off here. And this actually will show us how the internal consistency is working with this key generator as well. So if I toggle preview off, I look at customer key 16, the value in this first column is John, and I happen to know that there is another John value for customer key 45. I toggle preview on, so we can see the effects of the alphanumeric string key generator. Customer key 16, BEHJ, is going to be the same as customer key 45. So we can see that that internal consistency is being preserved. Obviously, this is not a key column, but that's just the way that the key generators will work.
Yeah, that's awesome. And I know that I think eBay is a customer of ours who particularly calls out format preserving encryption in a blog post that they wrote about how they use Tonic and how valuable that is to them.
Yes, big shout out to eBay.
Yes, shout out to, I always love a shout out to eBay because yeah, it's great to have that blog article from them. All right, so, you know, it's really great, like you said, utility, privacy, and that's a perfect segue into the number one generator on our list today. I feel like I want a drum roll, but instead I have a tantalizing question. Let's go with that instead. What can we use when we need to generate data across columns, and to shout out to our question answer earlier, row to row dependent data as well? Well, actually, I'll take that. I'll get back to that shortly. Let me go back to my original question. Sorry.
Yeah, no
what can we use when we need to generate data across columns in a way that achieves a high degree of data fidelity and privacy while capturing complex relationships within our data that we may not even realize exist?
Yeah. Okay. So this is a good question, and I'm glad that we get to show off this generator because it's very cool. Or I'll say kind of show it off, and you'll see what I mean in a minute. Basically, AI synthesizer is the generator that's going to solve this problem. Now, we've been talking and kind of seeing along the way the concept of linking different generators together to preserve relationships between columns. So I messed this up with my alphanumeric string key, but previously we had the categorical generators in first name and gender that were linked together to preserve those relationships. An AI synthesizer does something super similar, but much more sophisticated. It uses a deep neural network to train a model of your data that then generates highly realistic synthetic data to mimic those underlying relationships. So an example of when you would want to use this, if you suspect that there are complex relationships between columns, maybe you don't know what those relationships are. You don't know if there are dependencies, if there are correlations, how strong or weak they might be. You can use this generator to suss out and mimic those relationships. Let's just apply AI synthesizer to maybe a couple different columns here. I think it stands to reason that like marital status, annual income, largest bill amount, and store membership card. I think it's pretty reasonable to expect that there would be relationships between those values that might be too complex for me to just like name outright. So if I apply AI synthesizer to each of those columns, as I just did, while my data generation is running, Tonic is going to train a model that generates synthetic data in each of those columns with the intent to preserve the original relationships between them that the model essentially assesses out. And this doesn't matter how complex or how subtle those relationships are. I wish I could show you what that looks like, and especially like a comparison between this output data and the original data. One limitation, though, is that you can't see this in the preview very well. The data generation is when the model is trained and actually runs on the data. So that, again, is one unfortunate limitation of this demo. But one final thing I guess I'll note about AI synthesizer is that it preserves complex relationships between columns in specific tables, not between different tables and not between different databases. However, if you do need to do that, you would need an even more sophisticated machine learning solution. And as it turns out,
we have one. And this is why I kind of backtracked on what I was saying earlier about row to row, because this is the answer to the row to row situation as well. I'm excited to just quickly give a shout out to our latest offering, which is a new workflow designed specifically for data scientists who need to generate really high fidelity synthetic data while capturing complex relationships across tables, like you said, but also that row to row relationship, that longitudinal data that we had the question about earlier. This solution goes by the name of Jinn, that's DJINN, and it makes use of AI synthesizer under the hood to synthesize categorical, continuous, location, and yes, event data, that row to row data, with a high degree of fidelity and privacy in the output, and capturing all those relationships in very nuanced ways. It's particularly useful if you need to augment data sets where you've got like gaps in your existing data, if you're looking to fuel your ML pipelines with more realistic data, and obviously for safely performing data analytics while respecting privacy and compliance. So I would like to let everyone know, if you'd like to try it out for yourself, you can go on our website and create a free trial account by visiting tonic.ai/Jinn-trial. So that's tonic.ai/DJINN-trial. We would love to hear what you think. So do please go over there and create an account, play around. It's a pretty cool, different, UI and different experience from what we've demoed here today. So that's the answer to the row to row data of events. And of course, we always love to hear your feedback on Tonic itself. So I am going to open up the floor to questions. I love all the questions that we've already had coming through. Love how they were like so Hipaa targeted as well. If you've got more questions, please do toss them in the Q&A, toss them in the chat. Love to hear them. And I'll also toss some questions. Oh yeah, you can go ahead and stop sharing. I've got some questions for the audience as well. I would love to know, what's your favorite generator? If you've got one, if you're a Tonic user, what do you love? And whether you're a Tonic user or not, what would you like to see our generators do next? What are you looking for? What data scenarios do you have in particular that you'd like to solve for? So go ahead, pop them in the chat, and we'll stick around a little bit for questions. Let's see, for the differential privacy generator, can it be used across the table or is it column specific? I believe it is column specific.
Yeah.
Yeah.
Let me open up the chat here and just read the question myself. Okay, so maybe it would be helpful to clarify that differential privacy is not a type of generator, it's a property of specific generators. So I'm trying to think if there's a good example in this sample data set, but that might be the wrong way to go. Essentially, yes, to answer your question, differential privacy is like a property within a specific column. So it's essentially like if it's an option for a generator that you're configuring, what that generator is going to do is remove any outlying values to smooth out the distribution. So if you apply it to multiple columns across a table, it might be true for most of that table, but there are some generators that differential privacy does not work for. So
okay,
link note there.
Yeah, that's great. Thank you. And thank you for the question.
Thank you.
Yeah, I'm wondering if it's applied to two columns that are linked, for example. I guess that's kind of a way to extend it across certain columns within the table. Like if you had income and largest bill amount and you use the continuous generator and you made it differentially private, it's still, and you're linking them, it still captures those relationships while making them differentially private.
Yeah, I think so. I'll note that, I'll have a note and then I'll have another link shout out for everybody. Again, differential privacy is not an option for all types of generators. So if you don't see it there, that probably means because that generator wouldn't work with differential privacy. If that's something you're concerned about for again, all columns in a table or everything in your data set, I would recommend checking out the generator reference guide in our documentation. I have it up right now if that would be appropriate to link in the chat. That's right.
Yep. Yeah. That'd be great.
I link my customers to this all the time. It is the be all end all of generator knowledge. The Mixology 101 ebook is a little bit more fun to read, so still definitely check that out. But if you're looking for hey, I need to double check that all these different kinds of generators are going to be able to have differential privacy enabled. Oh, thank you, Chiara, you beat me to it. This would be the place to check for that, because generator by generator, you have all the different options that might be available or might not be, and why or why not.
Yeah. I mean, some generators, it doesn't even make sense to have differential privacy on. The first name, the name generator, it's pulling from a library. By default, it's as private as you get because it's not relying on your existing data.
Right. Exactly.
I think we also call it data free because it doesn't something like that is data free. It doesn't rely on your existing. Yeah.
Yes. Yeah.
Yep.
Good question though. Thank you.
Yes, that was a great question. And for that question asker, sorry, if you are interested in trying out Gen, we'd love to hear what you think, because it does sound like you've got some use cases that would be well suited to it.
Yeah, I'm just reading through some of the other chat comments here. Definitely, if this is helpful on rewatch, I would, definitely feel free to do that. Hopefully we didn't move too fast or anything. What I'll also say is that, and this is something that like everyone at Tonic, on my team, all of our customers do, just, if you can play around with the generators themselves, and like you can actually create a sample data set from within Tonic. It's the same data set that I'm using. That's the easiest and fastest way to like gain familiarity with all the different options. You can play around with stuff. You can see how the output data looks. Like there really is nothing like going in and, playing around with it yourself. So
yeah. Yep. Agreed. Excellent. Any other questions? We do have a couple more minutes left. Do you have a favorite generator, Dylan?
Do I have a favorite? That's a good
shipping
question.
Container.
There are so many that I use all the time, but I don't know if that's the same thing.
Yeah. No, for me, the favorite is like the complexity. The more complex, it's just like, wow.
I'll answer that. I think our customer's favorite is probably the company name generator. About once a week, a customer will write in and say, like, you'll never believe what what showed up in the company name column this time, or like a consumer, on that customer's team of that data will be like, where did you get these company names from? They're so ridiculous. So that's one I think that is like very popular. I don't know where we got that library, but I don't know. Obviously, either. Is pretty successful.
Yeah, I mean, and I was looking at the outcome. I feel like it's. I haven't confirmed this with engineering, but I think it's basically creates a string of, a combination of 4 words, and it'll end occasionally with services, industries. Like it's set up to end with those, but sometimes it's not just individual words; it's phrases. Like shooting star. That's 2 separate words, but it pulls in that phrase. Like there's just some really strange ones that come up sometimes.
But it's great fake data because it fits, but it's totally nonsensical and unidentifiable.
Yeah, exactly. I wish we had some more generators that were just like, the output is always fun. That's what it is. The output is always fun. Like I would love. That would be nice, wouldn't it? Yeah, I mean, I've asked the engineering team for a pig Latin generator, but obviously there's no need for that. It'd just be fun, right?
Yeah. Let me guess that our engineering team said no as soon as that.
Yes, they definitely said no.
They said we have more important stuff to work on.
Yes, more important stuff. And then the thing is, like once a generator gets in the system, it's never coming out because somebody's going to use it somewhere, and we're not going to take that away. So
one thing actually that came to mind as we were kind of talking just now, we have some preloaded libraries for different generators, like company name or like the name generator. If you're interested in uploading your own library, so if you want to make every generator really fun and nonsensical, the custom categorical generator is the way to do that. So it behaves the same way as categorical does. It shuffles the values, but the preloaded library is one that you upload yourself.
Yes, that is a great one to call out. If you really, that is a fun one. And we just had a request for a haiku generator. That would be a lot of fun. I think our data science team is looking into possibilities around text generation, free text generation. I think we recently have a blog post. Let me see if I can pull that up. But haiku in particular, I mean, that's pretty, I'm no engineer, but I'm going to say that's an easy lift. I mean, it's just 5 syllables. We can you can do that.
So
right?
Here's a question though. Would it replace the underlying values with haiku, like random haikus, or would it take strings and then break them into like haikuify them? I don't know. Something to pass off to engineering and product and say, you guys figure this out.
Yes.
This is a request. It's for you guys now.
Yes. Any possibilities of Klingon? Yes. There have been Klingon and different Elvish languages have often come up as requests internally. I will say those are internal team requests. Like somebody on sale said Klingon, and I said, if you're going to do Klingon, you got to do Sindarin. Like, sorry, sorry, not sorry. Here we go for all my Tolkien fans out there. Here's the blog article. I don't know, when I'm doing copy paste.
Oh yeah, it kind of came in twice. Yeah.
See if I can do that again.
I see what happened there. That's kind of weird.
There we go. So that's the blog article that we recently put out around free text generation.
That would be very cool, because right now it is like there's some workarounds you can do, but that has come up for some of my customers before, free text.
Yeah. I also see Quenya. Yes, either of those. Any Tolkien language is welcome in my book. Haikuify is my new favorite verb, and I have ideas for you.
Amazing.
That's awesome. If anybody's on Twitter, I will recommend on Saturdays, the writing community does a hashtag Saturday haiku, and you can just read all sorts of, like, it's a lovely way to spend your Saturday morning scrolling through some lovely haikus from all over the world.
I love that.
Yeah. Well, this has been awesome. And once we get to the point of chatting Klingon and invented languages, I think that's like a very high note to end on personally.
Yeah, agreed.
So I would like to thank everyone for joining us. I'd love to do this again. This was so much fun. We could do like a quick generator of the month show, you and me, Dylan. We can meet, transfer some data. Yeah, that'd be a lot of fun.
There's new generators all the time. So
that is true. We have more to spotlight.
A month from now, a year from now, there'll be even more to spotlight.
Yes, that'd be fantastic. And if you two would like to join in the Data Mixology Fun, we would love to hear from you. You can reach out to us on our website, or you can book a demo with someone on our team at Tonic AI. And if AI synthesizer, like I mentioned, is like all you need for data science and augmentation use cases, sign up for that free trial of Jin, tonic.ai/DJINN-trial. Let us know what you think. Awesome. Thank you, Dylan, so much. Really appreciate your expertise today. And thanks to everybody for joining us. This was so much fun.
Yes. Thank you so much, everyone. And thank you, Chiara.
Yes. Happy mixing. And remember, always fake your data responsibly. Cheers.
Bye, everyone. Have a great day.
Bye.